chance to try some of the problems out beforehand. Kind of give you an idea where you're at, gives me an idea where you're at too. For the order of operations, how did that go? You guys remember your order of operations? Yeah, so the acronym, right? What's the acronym for order of operations? Yeah, and the reason, what does PEMDAS stand for? Yes, perfect. So this is the acronym most of you probably saw at some point: parentheses, exponents, then you've got multiplication and division, and then you've got add and subtract. Now, one thing people don't always realize, though, is that multiplication doesn't always come before division. Addition doesn't always come before subtraction. The multiplication and division, these are actually kind of like on the same level. And so if you do come across an expression where you have multiplication and division, you should go left to right. And same with addition and subtraction. You could run into situations where you have, just addition and subtraction. You don't always do addition first. They always just go left to right. They're actually on the same level. Okay, so if we look at an example like the one we had, so come over here. Actually, I'm going to make this a little thinner. So let's say you had, what was it, 3 squared? So 3 squared minus 18 divided by 11 minus 5. So when you see an expression like that first one, where do you go first? Yeah, you want to go inside your parentheses. So then we can take care of that first. One thing that you're going to want to probably get into the habit of, and this is something, how much work you show is kind of up to you, but it's not a bad habit that when you're simplifying expressions like this, like trying to make them simpler using mathematical operations, it's a good thing to just do one step at a time and make sure you copy down the whole problem to the next step. So I'm just going to do one thing, copy everything down, one thing, copy everything down. What that helps you do is it helps make sure that you don't lose any things, especially we're going to get into negatives and positives pretty quick here. And with negatives and positives, the signs can get really wonky really fast. So it's really good to keep track of your work at every single step. All right, so that takes care of the parentheses. So then where should we go? So now we got an exponent. What is an exponent? That's an exponent, right? So when you have a number up in the top, and what is that exponent telling us to do? Yeah, so it's an exponent means repeated multiplication, right? And so 3 squared, right? So 3 squared is the same as 3 times 3. It's really tempting a lot of times. People will say 3 squared, oh, that's 6, right? Like 3 times 2. But you have to be careful. The exponent just means multiply the number itself by itself that many times. So then 3 squared, that would give us 9. And now, what are we down to? What should come next? Division, right? So there's subtraction and division here. We should take care of our division first. And so 18 divided by 6 is 3. Now we can finish it off. 9 minus 3 is 6. Okay. What questions do you have about that one? Any questions there? Following that, or why we did any of that stuff in order? Okay. All right. Perfect. So usually I'll go through these. When I go through solution sets, I'll usually go through them pretty quickly. So just ask questions as we go if you have them. All right. I don't always stop, but I'm always happy to stop and revisit things if you need me to. All right, so I'm going to move, and I do record these, so anytime I'm doing work up here on the board, I record those lectures, and those are the ones I post in Canvas. So you can always go back and watch them as well. Okay, so then we had this one. So 33 divided by 3 plus 8 times 2, and that one was right next to another one, which looked very similar. It was 33 divided by 3 plus 8 times 2. So they look very different, or they look very similar, but they're not going to give you the same answer, right? So what should happen in the first example first? What happens if we're over here? What should we do first here? Yeah, so now in this one, because there's parentheses, we should go take care of those first. So it'd be 33 divided by 8. 3 plus 8 here is 11 times 2, right? Whereas on this one, where would we go first here? So yeah, since there's no parentheses here, we would take care of our division and our multiplication before the addition, right? So this one would become 11 plus 16. So because of those parentheses, they turn into very different expressions, right? Okay, so we'll finish up the first one, and then I'll come back to the second one. So we go over here on the left side, 33. Now what should we do? So this is where you got to be careful. Yeah, so a lot of people, if you look at PEMDAS, M comes before D, so people think that you should multiply before you should divide. But that's not the case. Multiplication and division are on the same level, and so if you have an expression that's all multiplication and division, you should just go left to right. So we want to take care of this division first. So 33 divided by 11, what does that give you? 3, right? Then we can finish it off by taking care of the multiplication. So 3 times 2 is 6. So this one's also 6. Same as the last one. Yeah? Questions about that one? So again, multiplication and division, it's not like one always trumps the other. It just goes left to right if you have all in one expression. Now over here, though, we can do the multiplication and the division at the same time if you want because they're separated by an addition sign. Yeah, go ahead. Question.
Did you do the 11 times 2?
No. So that was what we were talking about. So this 11 times 2 shouldn't be done first because it comes after the division.
Oh, you divided. Okay.
Yeah, so the division should come first here because it's on the left, and then the multiplication will come last because it's on the right. Yeah? So then over here, though, the division gives you 11, the multiplication gives you 16, and then you just have to add them to combine them. So the answer here is what? 27. Right? And why are those? What made those answers so different? What was it that made the big difference here? Yeah, right? It's that here, the parentheses, man, I don't know why I'm having such a problem with that word today. Parentheses, what did it do? It forced you to add first. So that's the big difference, right? Whereas over here, without the parentheses, you would never do addition first. That would be at like the lowest level of order operations. But here, because it's inside parentheses, the parentheses force you to do it first. So. Okay? All right. So, like, this stuff is out of 2.1, and this whole worksheet's out of 2.1 and 2.2. So one thing you want to be working on as we go is, like, when you go home, then when you log into Canvas, then you want to be going in there, and then in the Chapter 2 module, you'll see, I told you yesterday, there's these suggested practice problems. Then you would want to probably be going in there tonight or sometime tomorrow and opening up 2.1, 2.2, taking a look at some of those practice problems. That's where you're going to get a chance to practice some more order of operations stuff and prepare yourself for the quiz that's coming up later in the week. Okay. All right? So let's go and look at some other stuff here. So we don't always do a ton of practice in class. I try to give you some stuff to work on, but I'm also expecting that you're logging on to Canvas and doing those practice problems for extra practice to prepare yourself for the quiz. And if you log on to 2.1 and 2.2 and you're working on those tonight, if you come across any that you have questions on, bring those to class tomorrow, and then we can work through them as a class. Okay. All right. So then briefly, these sections also touch on inequalities. So what's the idea of an inequality? Well, let's go back to black. So this one says that 15. How do you read that? How do you read that inequality right there? Greater than. Right. So the inequality always opens up to the bigger number, or that's what it's supposed to do. So this inequality happens to be true. Right? Okay, that was the first one. Then we had 11. So B was, how do you read this inequality right there? What's that line at the bottom mean? Yeah, so this is less than or Equal to. So equal to is allowed. So if they were equal, this would actually be true, but they're not. And is 11 less than or equal to 10? Definitely not. Okay? So that inequality should always open up to the bigger number. In this case, it's opening up till 10. So that's not that one's not true. What about C? This says 7 is greater than or equal to 7. Is that true? It is true. Why? It's true because of the... Oops, that's not what I wanted to do. It's true because of the fact that this right here means equals is allowed. Right? And so if they're equal, then the statement is still true. Yeah? If it would have been written as 7 is greater than 7, would that be true? No, that would be false. Okay. All right. And then what was the last one there? Is 41 less than 42? Certainly. Yeah, so that one's true as well. Okay? Questions on any of those inequalities or how to read them? Okay? So just always remember it opens up to the bigger number. The line at the bottom means equality is allowed. Equals can happen. Okay? We're not going to use inequalities an exceptional amount, but it is something that you want to have some familiarity with when you move on to your next class after Math 40. So we touch on them every once in a while. We deal with them every once in a while. Okay. Now, in part 3, what I wanted to look at here is what's the difference between an expression versus an equation. So I had two things right there. I have 2 plus x equals 5, and then I gave you the other one, which was x minus 7. So which one's which? Which one's an expression and which one's an equation, and how do you know?
The equation is 2 plus x equals 5 because it has an equal sign.
Yes.
And the other one's a statement.
Exactly. So if it contains an equal sign, then it's an equation. If it doesn't contain an equal sign, this is what we call an expression, or you could call it a statement. Okay. And there's an important distinction here, because this equation right here has a solution, right? So we're going to solve lots of equations in this class, but in an equation has a solution in the sense that for this to be true, there has to be a number that x has to be in order to make the equation true, right? So what's the number got to be in this case? X has to be the number 3, right? Because that's the only value you could put in here to make these two sides equal. So if you want to make this side 5, you got to make x equals 3. Now, this right here, we're going to jump right in, right, and using variables. Okay, so these are examples of variables. What is a variable? It's a letter, true, usually. And what were you going to say?
It's an unknown number.
Exactly. It's an unknown number. It's a letter that's holding the place of a number. So and that number is not necessarily known. Now, sometimes you can solve for it, right? It's like it might not necessarily be unknown, like something you can find, like here. This is holding the place value. If you want this equation to be true, then that x has to be holding the place of a 3. And then so then x has to be 3. But over here, what value can we put in for x?
Anything.
Anything, right? X could be 0, x could be 100, x could be negative 15, right? You can still drop it in there and combine those numbers and simplify. So the thing about equations is that equations typically have solutions, right? Whereas expressions are much more open-ended. You know, there is no fixed value for that expression on the right-hand side. This is like saying the example where this expression might apply would be like, my youngest daughter is 7 years younger than my oldest daughter. So what's my youngest daughter's age in terms of my oldest daughter's age? Oh, well, if you tell me how old my oldest daughter is, then I can tell you that my younger daughter is going to be that minus 7. But you don't know what my oldest daughter's age is right now. So you just write it as an expression until I tell you what that number is. But I can give you any number for x. And it's going to change the age of the younger daughter. Whereas over here, this is fixed. It's got to be 3. Does that make sense? Okay. All right. So if you have an expression, though, so expressions can be simplified. And that's what I wanted you to do in the part, what is that? I skipped a part, didn't I? So like in the last example, if I tell you how old my oldest daughter is, you could actually plug that value into the expression and find out how old my youngest daughter is. So in part 4, it's all about evaluating expressions. So like in part A, I said 5x minus 4 when x equals 6. And I use that term evaluate. So what does it mean to evaluate an expression? Yeah, it means to plug in a number. Okay, so we evaluate expressions a lot of times with formulas. So like you guys are talking about how you took geometry and it sucked and you hated geometry. But there's a lot of formulas in geometry. And so evaluating formulas, what that really means is you're just plugging in values. So if I was going to evaluate this, and what did you come up with here? So if we evaluate it, what do we do? We plug that 6 in for the x, yeah. So now what's the operation here? There's no operation specified here, so what are we supposed to do with the 5 in this number? Multiply, right? So if there is no number, if there's no operation specified, so it's just like 5 next to a variable, that's telling you 5 times x. So then, order operations, what should we do here? 5 times 6 is 30. And 30 minus 4 is 26. So an expression can take on a single value when you evaluate it, but that value could change based on what number you put in. So expressions are very open-ended. You can change the x value, and that's going to change the expression. The other one, you could have multiple variables. So this was part A I had you look at. Part B, this was x squared plus 2x minus y. And I wanted you to do it when x is 4, y is 2. So one thing that I recommend is if you're plugging values into an expression, I like to plug them in inside a parenthesis to make it more clear what's going to have to be done here. And this is really going to help us out a lot. Practicing doing it like this helps you out a lot when we start dealing with negative numbers. So in chapter 2, everything we're going to deal with is all just going to be positive. We're going to deal with positive numbers here at the beginning. Then in the next chapter, then we're going to start throwing in negative numbers. All right, so here, what should be done first? Order operations? I mean, I plugged them all in parentheses, but there's nothing specifically in parentheses to be done. So where should we go? Yeah, so there's exponents here. That should be evaluated. So what is 4 squared? It's 16. That's 4 times 4, right? Then you could do the multiplication at the same time, but I'll just, for simplicity's sake, I'll just rewrite it. Then you would take care of your multiplication, right? Okay, and then now we're in a situation where we got addition and subtraction, but we're not going to honor one over the other. We're just going to go left to right. So then we should first add. So 16 plus 8 is what? 24. And 24 minus 2 is 22. So that would be your solution. Okay. All right. Questions on that one? Everybody feel okay with that? Okay. Now, in this case, you're actually plugging values in. So that would be considered evaluating expression. Sometimes you can simplify expressions. This will probably be the last thing we'll have time for. We'll finish the rest of it tomorrow. But simplifying expressions isn't the same as evaluating. So I gave you an example of 10x plus 3x, right? Now, this is an expression, not an equation. How do we know? There's no equal sign, right? I'm also not giving you a value of x to evaluate it at, so you can't plug a number in and get one number out of it. But what's true about these two terms? They're both x terms. We call these like terms or like values, but they're like terms. So I've got 10 x's, and then I'm going to add in 3 more x's. So at the end of the day, what do I really have? What I really have is 13 x's. So when you have like terms, like they're both x terms or both y terms or a terms or whatever, if they have the same variable here, then you can combine them together because they're like terms. And this is more simplified than that. Because to solve this, all I have to do is one multiplication. If I were going to try to evaluate this, I'd have to do 2 multiplications and add them together. It's more complicated. So it's a more simplified expression. And so you can go across multiple terms. So like here, the one I gave you was 6y plus 4y plus y. What's that going to come out to be? It's got to be 11y. If there's no number out front, what is this really?
1.
Yeah. We don't really write the 1 there because it's kind of redundant. But if the y is out there, well, there's just one of them. So 6 of them plus 4 of them give you 10, and then you tack on an extra 1, and that gives you 11y. All right. And if you have multiple terms, but they're like terms, you can combine those. So, sometimes it helps to rearrange. So like here, I see that I have x terms. So I could rewrite this with the x terms next to each other. And then I could rewrite it with the numerical terms next to each other. Right? Now, the important thing, and we're going to talk about this more later, but if you're going to start moving terms around in an expression, you need to remember that the sign goes with the term. So this was a plus 4x here. So when I moved it over here, it stayed a plus 4x. And now you can combine your terms. So if you have 8 x's and you add 4 x's, how many you got? That's a 12x. And if you have plus 7 and then you take away 5, how much you got? You now have 2. Yeah. And so that would be the solution to that one. Okay? So we're out of time. I'll finish going through the solutions of these tomorrow. In the meantime, make sure you're logging Canvas. You got to take your syllabus quiz by today, so don't forget if you haven't taken it already. The syllabus quiz is due today. And I will see you all tomorrow.